So let's see if we can do number 11 out of 10.2. They want me to find a formula for an inverse function for m of x is 1 over x minus x. Good. That's a great idea. Call it y. I'm not doing that. I'm going to call it m. So I'm just going to say m is 1 over x minus x, right?
Yeah.
And what do you do?
Make a bubble chart.
Yeah, you could try to make a bubble chart. Bubble chart is challenging for this one because there's two instances of x, right? So you could like try to find a common bottom or something. No. You definitely could write it as x to the negative 1 power. It will not help you here. What you could do is you could say, okay, x is really x squared over x.
Yeah, then you
Right, and then you could try to combine. I'm not sure that this will work. I'm going to do it the other way.
Wait.
I'm not sure it's going to work, so I'm just going to try the other way because it's faster. So what do I do? Solve for m?
You add x.
No, I have it m. I have it solved for m. What do I want to solve for? X, right? So what do you do?
Both of them are the same number.
So you add x.
Add x to the other side?
Yeah.
You got m plus x is
1 over x.
1 over x. Then what?
Then you
Multiply
multiply by
both sides by x. So you got x m plus x squared is 1. Not wrong.
What?
That's wrong.
No.
You can't get it.
Oh, that's just
Can we
subtract the one? You can't get rid of it.
Let's subtract the 1.
No, so you get x times n plus x.
Factor out an
Oh.
x.
Could you minus x squared and then divide by x? No, it doesn't have to.
Factor out an x.
Okay, if you factor an x out, you get x times m plus x equals 1.
Yeah.
Excellent. Done.
Good. What do you do with this?
You put a square around it.
No. I need to get x equals some function of m, right?
So you do.
You guys see that? I'm not going to get that to happen here. This isn't going to, that's not going to
There
work.
is no inverse.
by x and you subtract that?
Yeah.
Yeah, that'll get me back to the beginning.
That's the answer.
So I don't know that there's no inverse at this point. What should I be wondering though? Like, maybe there isn't an inverse, right?
Trying to graph it.
So this thing's definitely a function, right? But it's possible that it doesn't have an inverse.
Yeah.
What would I need to check if this thing has an inverse?
If it passes the horizontal line test.
Yeah, I want to check if this thing passes the horizontal line test. How do I do that? Yeah, I want to know if there's any number that gives me this same output for two different inputs, right? What's the easiest output to check?
1.
Yeah, 0 is the easy output to
No.
check, right?
Pi.
So maybe let me think about, maybe I can check and see if this fails the vertical line test by just checking the easiest.
Yep.
Okay.
Are there two numbers, x, that you can stick in here and get 0 out? Like, how could I solve this? What do you do?
1.
Okay, so 1 is definitely a solution. Got another one? Right off the top of your head? Negative 1's a really good guess. Does it work?
It's negative 2.
Wait. Actually.
Or negative
1 over negative,
It's negative
1 over negative 1 minus negative 1 is 0. How could we have done that without guessing? Right? So this tells me oops. This tells me right now that m fails the horizontal line test.
Yeah, you know inverse.
Okay, so I do not have to try to invert this, right? Because I know I can't come up with an inverse formula. How could I have done that without guessing? How did I know that there was going to be some funkiness in this solving process? Like,
Because there's two X's.
There's two X's.
okay, there's two X's. It doesn't easily reconcile to one as a clue, but not a guarantee.
How did I waste my hand? When you did the thing earlier, when you had an x squared at the top, that would have given away that there was a parabola.
Good. You guys see that? This thing right here is a parabola intersecting a horizontal line, right? That's a parabola with an m parameter in there. But roughly, this is a parabola and that's a horizontal line. Parabolas usually intersect horizontal lines twice. Do they have to intersect horizontal lines twice? No, they don't. They could miss completely or they could hit it once. But that's a clue that maybe I'm having a problem here. That was also clued in by the fact that trying to solve this, right? My best bet for trying to solve this was to subtract one to the other side and try to like quadratic formula or complete the square or factor or something. That was going to give me two answers. Or at least it was going to try to give me two answers. You guys see that?
That gives you an option of n to the negative 1 equals negative x plus square root of x squared plus 4 divided by 2.
The book what?
10.2, number 11 for the answer.
Okay, what's their proposed inverse?
M to the negative 1 equals negative x plus square root of x plus 2 close parenthesis over divided by 2.
Whole thing.
Yeah, just, yeah.
Yeah, so what'd they do? So why did they?
They fucked up.
Yeah, they fucked up. They used the quadratic formula.
X plus 5.
Oh, doesn't matter. So, they used the quadratic formula to get an answer for this, right? You guys all see that? What did they neglect? Yeah, they neglected writing a minus here. So, is this actually an inverse function? No, it's not even a function. You guys see that?
Because that's where it's not going to be a function. Right?
Yeah, I knew this wasn't going to be a function because it fails the horizontal line test.
Well,
right?
isn't that
It's-
where it's still not going to be a function too? It's not going to be that. It's not going to be the vertex.
This guy here is telling you that this thing fails the horizontal or the vertical line test.
Yeah.
And I knew it was going to because the function I started with failed the horizontal line test. You guys see that? So your book apparently thinks that they can get away with this shit, and I don't think you can. Cool?
Inverse sine cosine though, we just kind of cut out a piece of it. Can we
Yeah.
possibly do that here?
Yeah, we could restrict the domain. Inverse sine and inverse cosine, right, are not actually inverse functions. Right? They're just partial inverses. That's what this thing is. So them saying this is them going over here and saying, okay, we got a function that fails the horizontal line test, so we're just going to restrict the domain, and they're going to cut it when they do the quadratic formula by just neglecting the negative side. You guys see that?
So would they have to put in what they restricted? And
They should have, but I bet they didn't.
Yeah.
Because it's hard to figure out what they restricted.
Yeah.
You guys see that? The best way to figure out what they restricted is to graph this and look for where it fails the horizontal line test. They actually cut out more than they had to when they did that. But shit happens. Cool? You guys good with this? So sometimes you'll see this approach where we'll just make an inverse formula. It's not actually an inverse. I want you guys to be more careful than most people are.
So if we get something like this on an exam, just put not invertible.
Yeah. If you can tell me that something fails the horizontal line test and I'm asking you for an inverse, just tell me it fails the horizontal line test, it doesn't have an inverse.
And this is, you said you didn't earlier this week you didn't want us to worry about the horizontal line test.
I don't want you to worry about horizontal asymptote.
Okay.
Yeah, I want you guys to worry about the horizontal line test. You can think about it as right? I would flip the graph across the line y equals x and then perform the vertical line test to test if the inverse is a function.
And the vertical would just make all the x's 0, right? you would to do the
vertical. Yeah, so flipping a vertical line makes a horizontal line.
Okay, yeah.
That's because the X.
Cool.